Hello, Mr. Q. This is Mostafa, and this is my performance task for calculus. So we're going to start off with question 1, part A, which contains this equation that we're supposed to balance. So pretty much the way I started this is I looked at this arrow as an equal sign, and I figured out, I gave each atom or molecule a value or like a variable of x1, x2, x3, x4, and then I proceeded to do, as I said, act like it's an equal sign and looked at each molecule. Like for example, iron, there's two iron molecules here, or on the other side there's only one. So as you can see right here, I did the exact same thing, 2 times x1 and 1 times x3. And I did the exact same for oxygen and carbon, and those were my 3 equations. And then, so to be able to solve matrices, I brought everything in here to the left side, because to solve it, I can't have everything on opposite sides. And then I ended up with these 3 equations right here. 2x1 minus x3 equals 0 for iron. For oxygen, 3x1 plus x2 minus 2x4 equals 0 for oxygen, and for carbon, x2 minus x4 equals 0. So now that we have our 3 equations, we can set up our matrices, which is right here. So pretty much for each value, I just put it in the matrices and I solved. And after solving it, I got these values right here. And then I divided it by its denominator to receive whole numbers. And when you get the whole numbers, you pretty much sub in the x4 values for each one, and then you multiply it to make it a whole value. And after you do that, you bring to the negative to the opposite side, and then you end up with these values as your x values. x1 is equal to 1, x2 is equal to 3, x3 is equal to 2, and x4 is equal to 3. And that's pretty much the values given in the formula, and then you just plug it in. So 1 times x1 is, for this part, 1, 3 times x2, 3, as you can see I underlined it, and for x3 is equal to 2, x4 is equal 3. And now for the part B question with the different formula that we had to balance. Pretty much the exact same process. I looked at each molecule as a separate variable, x1, x2, x3, x4, and I did the exact same process where I put it into equations and put them all to the left side. I just fast forwarded it pretty much. And the only difference with this part is I have 4 variables instead of 3. And after having my 4 equations and variables, I set up the matrices again, right over here. And I proceeded to solve the matrices, and in the end, I got this as my solution. So I subbed in x4 to equal 3 so I can get whole numbers and solve it. And I pretty much just subbed it in and simplified. And it's exactly similar to the part A1, and after doing it, I got x1 equal to 1, x2 equal to 3, x3 equal to 1, and x4 equal to 3. And in the end, my balanced equation is right over here, where, as you can see right here, my x2 and my x4 values have 3 right before them. Alright, so now for the second question, we had to find x values for a maximum area of a triangle, and we're given a parent function, which is right here, and we're also given the restrictions. So as we all know, the area of a rectangle is width times length. So pretty much to make it easier on myself, it was exactly the same thing as saying area is equal to x times y, and we're already given the function or like the y value. So I just subbed in the y value into this area equation right here, and we got this right here. So x times a square root b, and inside the brackets 8 minus x. And as we all know, the square root of x is equal to x, and then I just expanded it. So when it was expanded, the a became a squared times b, and inside the brackets 8x squared minus x cubed. That's exactly what happened right here. and those were all inside the square root. And then after solving it and fully expanding it and foiling it here, I just took the derivative, which was through the quotient rule, and I verified this through a derivative calculator. So pretty much, as we all know, a square root is the same thing as saying to the exponent 1/2, and because it's quotient rule, there's the -1. So then you just move the 2 to the denominator right here, and you get this as your derivative. And similar to optimization questions, you just like move the denominator up here, and then you end up with the numerator alone. So right here, this is what happened. I ended up having this, and because a squared and b are constants, you can just factor it out, and which is what happened right here. And you end up with a squared b, and inside the brackets 16x minus 3x squared equals to 0. That's after you put them in the brackets. And then you pretty much just cancel the a squared b out by dividing both sides by it, and you end up with 16x is equal to 3x squared. And when you solve for x, you end up with 16 over 3. And I can show you right here on Desmos. So as you can see, I plugged in my area equation formula, and as you can see right here, 5.333, which is the same as 16 divided by 3, is the x value that always gives the maximum area, no matter what the b value and a value is. As you can see, it will always stay the same. Let me zoom out. There you go. The maximum value will always be this value, 5.333. And just to as an extra, you can prove it by multiplying x and y. So let's pause this. Whenever you have an x value, just multiply it by this y value. And just like we learned the same skills as limits in the limits unit, just take a value close to that number and multiply it, and you'll always find that no matter what it is, this one gives the maximum area. Alright, and now for my third and final question of this performance task, question number 3. Reflecting on my work habits, I believe that for this semester my work habits were pretty good. I actually worked pretty hard for the whole semester. Yes, I did struggle on tests, but I believe that the amount of effort I put in terms of homework, class attention, and attendance, and doing my best every time I go there, I believe my work habits were pretty good, and I think they did prepare me for university next year, because I believe I'm a hard worker, and how my solutions to the previous question demonstrates my understanding. So I pretty much, through these 2 questions, I proved that I can solve the derivative of any equation, and I know how to use the derivative to retrieve information regarding graphs, and how to use these graphs to prove a certain point, or prove a certain, or answer a problem or a question. And in terms of the chemistry question, I showed how I can use matrices and find for unsolved variables and balancing equations. And one thing I found interesting throughout the semester is how much calculus is connected to, or how it can be applied to multiple things in real life, like the melting cone, the hot air balloon questions. All those questions I really found interesting, because most people say you can't use math and apply it after you're done learning it, but this is proof that you can actually use it for other things, and I found that really interesting. And in terms of marks, I believe the mark I deserve in this class is in the range of 75 to 80%, depending. That's me being fair about my results on tests, but also taking in consideration the amount of work I put in and how much I studied for each test. I believe test is just a weakness of mine, and I'll work on it, and that's pretty much it. Thank you.